Hi everyone, I'm Caden with FTC Team 14712, Ruckus Robotics. In FTC Robotics, we often use a lot of commercial off-the-shelf parts in our robot designs. Luckily, a lot of those parts from the common vendors like GoBuilder or Rev or AndyMark have Onshape models already made, so we don't have to recreate those parts or import them ourselves. These parts are available in the FTC Parts Library. In this tutorial, I'll guide you through the process of using the FTC Parts Library to create an assembly in Onshape. So we're going to start by inserting in a blank assembly. If you look in our current document, we don't have Part Studio, so there's nothing to use. So we'll instead go to Other Documents, and there you can see a bunch of different folders and teams that you're part of. In this case, you want to go to FTC Robotics Part Users. That will contain all the folders. Inside this folder, you can see all of the different vendors like Rev, MasterCar, GoBuilder. In this case, we want to use GoBuilder, so we're going to go to GoBuilder. And now we're going to start. So we want to probably get some hardware, in this case screws, so we'll go in the hardware folder, scroll down, go to screws, and in this case you can see folders for all the different screws. If we go to this first one, you can see the same screw with a bunch of different lengths, but we can basically achieve the same thing using configurable screws. So we'll scroll down and take one of the configurable options. 12 millimeters is good, so we'll take that in, and we'll put it into our assembly. Now that we're done with that, we want to leave the screws and leave the hardware folder. We want to add our next piece. In this case, we're going to go to structure, and in structure, we'll scroll down to channels, and we'll add the low side U channels, in this case, the configurable option again. And then we'll do 3 holes. And then drag that onto your assembly again, and you're done. We'll take 2. Okay, from there, we are going to add our next part. So we're going to go out of channels. We'll stay in structure. In this case, we'll add some standoffs. We'll go with this round standoff over here, the configurable option again, and we'll do, let's see, 48 millimeters should be good, and we'll put that in. Okay, now we'll do our next part. In this case, we're going to go out of the structure folder, and then we'll go to motion. In motion, we have a couple parts we'll need. We'll start with the bearings, so scroll all the way to the bottom, go into the ball bearings folder. We'll take the flanged bearings, and then in this case we want the Rex bearings. So you can see that there's this Part Studio option, and then there's assembly. In this case, the bearing is in assembly, so we'll take it from the assembly option. And you can see that little revolute mate there, which is part of the assembly, and that's important for when you're actually putting together your model. Now we need to add a shaft collar, so we are going to exit all of these subfolders, and then we'll scroll through motion again. Over here. Okay, so we'll enter this collars folder, and we need a set screw shaft collar. So we'll look for this 8 millimeter Rex bore one, and we'll insert that. Done. Okay. The next part we need is a gecko wheel. So we'll look through motion again. And then we'll go to this wheel and tires folder, and then find the gecko wheels, and we'll put this first one in. Now the next part we're going to need is the shaft that our wheel will be on. So we'll look through motion again, and go to this folder, shafting and tubing. You can see all the options, but we'll use the configurable one again. We'll take this little steel shaft with an E-clip, and then we'll do 80 millimeters. Okay, so we'll input the whole Part Studio in, with the E-clip as well. Okay, so now we have all of our parts in assembly, and we should be ready to assemble. First, we'll do a fasten mate on the standoff. Make sure you select this top face and not this second edge because of this chamfer. And then we'll mate it to this corner of the U channel. And then we want this in a couple other places, so we'll use replicate. So we'll select the standoff, and then the mate is automatically selected. we'll change this to match individual edges, and we'll select all of the different points that we want the standoff at. Once we've done that, we just want to mate the other side. So we'll take the U channel, that little corner mate, and mate it again to that face. And now we have the basic structure formed. Now we got to add our screw, so we'll do another fasten mate. We'll turn on our mates to show the mate, so we'll take that mate connector that's already on the screw, and then we'll add it to there. And then we need to flip the direction because it's facing the wrong direction. So we'll use that little button there. We'll check that, and we'll replicate again. This is another good use for replicate. Let's add it to all of the holes where the standoff is. Okay, now we want to put the bearing in the channel. You can see right now I have just one, so I'll need another. If I just copy it like that, you'll see that it's just a part, which is not what we want. We just want we want a whole nother copy of the assembly. So what I'll do is I'll select the assembly in the instance list, and then copy it just like that, and then I can paste it. Now I'll just fasten it. So I'll take the flange over here, and then put it in the U channel, and then I'll do the same thing with the other one, just another fasten mate. This is somewhere where you couldn't use replicate because you're doing an assembly. And then, okay, so now our bearings are in. Now it's time to do the shaft. So you'll see that this E-clip is separate from the shaft. It's not mated or anything, so we need to mate them or group them together first. So I'll select the two, and then I'll group them. Okay, then I'll fasten mate the inner side of that E-clip to the inner race of this bearing, and flip the direction, and then now it's fastened to the bearing. Just to keep this from moving around, I'm going to use fix on the C channel. Fix is just a temporary thing to help you build it. It's not really a mate, so don't use it as one. But here we can see the shaft rotating. This works because I'll show you because of the revolute mate on this bearing. So because we fasten made it to the bearing, the shaft will now spin because of the revolute mate on the bearing. Okay, next we'll attach a shaft collar to the other end. So it's just another fasten mate. We want to use this bumpy side of the bearing, and we'll attach it to this inner race of the bearing over here. The reason that we use this bumpy side is so that the shaft collar only contacts the inner race, so it doesn't have friction with the outer race. I'll undo that section view, and then we can see how it's spinning. Okay, so for the final part, we need to attach this gecko wheel to the shaft, and our goal is to have it in the middle between the two U channels. So we could use a fasten mate and attach to the shaft and do an offset, but I think a slider mate will work better in this situation. So we'll take the center of the wheel, and then we'll just mate it here. And the slider mate will allow it to slide along the shaft, but it'll constrain it to the shaft rotationally. So now you can see it sliding. And now that's attached there. And now we need it to be in the middle perfectly between the two channels. So what we can do is use this width mate, and we can select one side of this. So in the tab mates, we can select one side and the other side, and then we select the left U channel over here, and then the right U channel. And now our wheel will be perfectly in the middle, and you can see it rotating.